Hello friends, welcome to this video. In this video, we are diving into properties, and we're picking up where we left off in this little series that we started where we're taking a look at Python code, especially from the perspective of people who are maybe beginners, intermediate to Python, and we are covering some topics using cryptocurrency exchange data as kind of our prop. So kind of moving away from the traditional hello world, bringing in something that's a little bit more real world and learning as we go. So in this video, I really want to illustrate what is the reason that we use this property decorator here in this class. This is something that you don't have to do. This is something that is very useful to do in a lot of situations though. And properties are something that if you really understand how they can be useful for you, can just help to enhance your workflow. Kind of like if you need to get from point A to point B and you have a bike available and it's just as good to walk or to bike. If you use the bike, you're going to get there faster. This is very much the same thing with a lot of these features that come with lots of things in Python, including the ability to set properties in your classes. So for starters, let's just learn by doing, and we can run this code that we had already at the end of the previous video, which is linked in this video's description. And we can see that whatever we built before is returning to us something that we can call on, and we can see these Gemini symbols. If we take a stroll down memory lane, we would see that Gemini symbols are kind of a prerequisite to us being able to get all of the prices for that symbol, and then stuff those prices into a pandas data frame. And as we loop through all of the symbols, we end up at the end of the day with a data frame that describes all of the prices for all these symbols available on the exchange. And the nice thing is we're getting these Gemini symbols not from some static file where we've defined Bitcoin, Ethereum, blah, blah, blah. This is actually something that's happening. Let me delete this. We're not there yet. This is actually something that's happening for us by calling on this thing that is a function, but that gets treated as if it's a variable. You see how when I call on Gemini symbols, there's no parentheses after it like you would see if you're calling on a function. Instead, this thing gets treated as if it's a property of my class, which indeed, if you think about it, it really is. And I'll just make a side note here because I work with data really closely, and I'm very often building classes that are doing some sort of analysis, and there are oftentimes things that really make sense to think of as properties of your analysis. Kind of like if instead of an analysis you were baking a cake, you might think of the flavor of the icing as a property of that cake. So if I'm doing an analysis and there's the analysis equivalent of icing on my cake, then I'm going to want to treat that as a property in a lot of ways, maybe even in my code. Now what happens when we make something a property is you're going to call on this function that gets treated in a lot of ways as if it's a variable. And when you call on that function, some logic, whatever you've defined inside the function is going to get executed. And at the end of the day, whatever you return is the thing that's going to appear to you as the end user, like that this is the value. Whatever's returned here is what you end up seeing when you call on this thing. So when we go back to the code that was executing, we can see we called on our Gemini symbols and it outputted this list. So that's one aspect of properties, and another aspect is that this value that's actually returning to us is something that we'll oftentimes want to store up here in the class, and it's something that we can keep track of. Like in this case, when my class gets initialized, I say that my Gemini symbols are none. They don't exist yet. So when we call on Gemini symbols down here, the logic is hey, is there anything inside Gemini symbols? If there isn't, if this thing is none, then let's go ahead and reach out, knock on the door of this API and get some data from it. But if this thing has already run once before, then this self._Gemini symbols is no longer going to be none. It's actually going to have data in it. And so it's kind of it's redundant. It's a waste of energy for me to go out to that API and grab those symbols. In this case, now there are situations where you would not want to keep pointing to the same values. What if your symbols change every 5 minutes? But in this case, that isn't happening. So this is very practical to be able to say, if I call on this thing, a million times in the course of a regular analysis, and all of those million times, this is expected to just be the same value. Well, why not do this little trick, and I can just run the query out there to get those symbols once, and then after that, I'm just pointing to this object. All right, so we stepped out in the weeds there a little bit, but this is why I use properties a lot, and I'm trying to convey a practical use case for using these things. In some code reviews that I've been a part of, people ask, hey, why do you use properties so much? And the answer is oftentimes in my head, it's, well, because this thing that I'm pointing to is a property in my mind of the class I'm working with. It's not a function. Like, I don't want to go around building 100 get Gemini symbols functions, because a get Gemini symbols function can be simply replaced by a property that simply says Gemini symbols, and every time I hit that thing, it's going to act as if I were operating on a get Gemini symbols function, except it doesn't actually have to always execute that code. It's just pointing to this underlying value, and I save myself some time. Now, another thing that properties bring to the table is this light layer of protection. So let's say that I come out here to the code and I try to directly change what Gemini symbols is. Let's just say we want this to be a garbage value, and let's see what happens when I run my code. So Python's not going to like that. It's going to say, not because it's a garbage value, but because this thing is a property, and you can't just change a property like you can a normal variable. So that's kind of a layer of protection. Like, if I come in and I actually change my time frame, that's not a property. Let's see, am I going to be able to change that? Gemini dot change or dot time frame equals some other time frame that actually sucks. It doesn't exist. So I'm going to run this, and it's not going to complain to me about that thing. All right. Well, actually, just to be fair, let's get rid of this one so that we can see that there is no error, no exception gets thrown. We just get this less great time frame that's actually set. Okay, so if we go back to our other code over here, let's see if there is something that we could do to make a property play ball with us. Like, let's say we do actually have a use case where we want to change Gemini symbols. Could we allow someone interacting with this class to actually change this value? And before I show you the better way, let's see the worse way. If we know that our Gemini symbols is actually pointing to that underscore value, we could actually just change that. Now, this is something that's frowned upon, because if I look at attributes of this class that are available to me, we're not going to see underscore Gemini symbols. So if you're changing underscore Gemini symbols, it's because as a developer, you're really trying to do this. So when you have a property, you're not going to directly set that unless you've defined a setter for that property. Now, that doesn't mean that property is completely protected and that it's a private variable or pointing to a private variable, but this is what you would call a protected variable in Python. If you're a developer and you're changing things that begin with single underscores, you're kind of playing with fire, and it's a known thing that's not really the way you would want to design your code, that someone would be interacting with an underscore value unless they really know what they're doing. So what we can do if we want this to actually work without having to beat around the bush and point to an object that we really shouldn't be overwriting. By the way, let's just double check that this is doing what we think it is. So let's print out Gemini symbols now, which remember at the end of the day is pointing to this guy. And if we run this, we're going to see that there is no exception this time. And the second time we print Gemini price fetcher Gemini symbols, like this is the exact same print statement down here, but instead of getting our list of symbols, we get that garbage value. So now let's see if we could do this without beating around the bush, and can we actually make this thing a value that we can set as someone interacting with the class? And the answer is yes, you can do that. We're going to write the thing that I deleted earlier. So what we do is we say we have this property Gemini symbols. So let's take Gemini symbols and let's slap a setter on it. And this is going to be a function that is also named Gemini symbols. And we're going to pass this thing a value. And let's just say that that's a list of strings, slapping a type annotation on this. By the way, if that looks like magic to you, go check out the first video in the series. I'll link that in the description as well. And this isn't going to return anything, but what it is going to do is it's going to set, let's just say, sets a new value for the Gemini symbols. And we could probably come up with a better doc string than that, but you know, we're flying by the seat of our pants here. So let's say that this is just going to do self._Gemini symbols equals whatever the value the person passed in. So now if we come back out here, we should see this exception go away. And instead we're going to end up with a garbage value. And let's go ahead and print out whatever that value is. And when we run this, we're going to see, all right, our property now has a setter defined. So it's not complaining when we try to set that value directly. So this is something I like about properties. They remove the need for you to use getter methods. So you don't have to go around writing get Gemini symbols, get cake icing flavor, get all of these things. It's a getter by default. So you can treat it like a variable, but you can also put more complex logic in it. It makes it pretty easy for you to do things like this kind of basic caching where I'm only going to go look up my Gemini symbols once, then I'm going to reuse the value that this points to. And then it also prevents you in some ways from accidentally overwriting values that shouldn't be overwritten. Of course, you can come in and hit this protected variable directly because Python doesn't have as strong a protections as some other programming languages do. There is no concept of a private variable, a truly private one that you can't modify in a class. But it's going to make it a little bit harder for you to mess that up for yourself and make it to where if you are messing things up for yourself, you really intended to do so or someone else did. And so then we can, if we want to, create that setter for our property. And so once again, by default, your properties are going to have getters baked into them. We don't have to define a getter method. This is our getter method. And then we can define an optional setter. But if we don't define the setter, then you're going to get an exception thrown whenever somebody tries to modify that value. It's kind of assumed that you don't want this thing set if you are using a property that that doesn't have a setter defined. All right, so that's it for this video. In the future, we're going to revisit some of these topics about classes, maybe even get into class methods, static methods, and then we are just going to keep going deeper down this rabbit hole using some of this cryptocurrency data to maybe even touch on some analysis techniques, some regression things, basics of machine learning algorithms. So stay tuned if you're interested in this stuff. We're just going to keep learning about Python, keep using cryptocurrency data, and I hope to see you there.